Good morning, good afternoon, good evening, wherever and whenever you may be. My name is Jeff Wuendry, and I'm part of the mobile automation group at SICK, and that was my attempt at kind of showing linear motion. Because today we're talking about the MAX48 Linear Encoder, which is an excellent choice when considering adding this to your agricultural, construction, mining, forestry, and industrial vehicle. We'll talk about it here in a second. Stay tuned. If you're adding automation or creating an autonomous platform on an agricultural, construction, forestry, or mining vehicle, you need intelligent sensing solutions from SICK. From a location near the SICK headquarters in Minneapolis, this video series explores the latest trends and the newest products for off-highway, off-road mobile automation. We have work to do. Let's do this.
Hi, my name is Jay Johnson. I'm the Market Product Manager for Motion Control Sensors here at SICK. Motion control sensors include encoders, inclinometers, and linear position sensors.
Thanks, Jay. Are you ready for 4 questions? I guess the first one is, what is the MAX48 Linear Encoder used for?
Thanks for the question. The MAX48 is a linear position transducer that, when mounted inside of a hydraulic cylinder, will provide the position feedback to within 0.1 millimeter resolution. The sensor itself is mounted into the rod, while a magnet is embedded into the piston, and as the piston travels up and down the rod, we get the output in either CAN J1939, CAN open, analog, or PWM output. So it's really designed to interface with just about any of the vehicle control systems on the market today.
Hey, thanks, Jay. Hey, now that we know what it's used for, can you tell us a little bit about the product?
Hey, Jeff, that's another good question. So the MAX48 works on a principle called magnetostriction. The electronics in the head will create an electrical charge, which is then transmitted down a wire that is inside this tube. As the current travels down the wire, it creates a magnetic field. That magnetic field will eventually collide with the magnetic field from the magnet embedded into the piston and be sent back to the receiving electronics in the head. The head measures the time that it took from when it transmitted the charge until the charge was received. So basically, time of flight principle. This is how we know the position of the piston within the cylinder. That electronic signal is then conditioned, converted to, say, a J1939 or an analog output, and sent back to the ECM for evaluation and control.
Thanks, Jay. That was the second question, but maybe we should back up just a little bit. Are there any new products coming out?
Sure, Jeff. The MAX48N gets its name from the 48 millimeter diameter body, which is a fairly standard dimension in the industry. We also have recently released a MAX30. The MAX30 has, of course, a 30 millimeter diameter body, which lends itself better for smaller cylinders that may be used in steering applications or, say, automated forklifts. Notice the MAX48N, MAX48N, has a connectorized top in which the cable can be replaced in the event that it ever be damaged. We do also have a recently released MAX48A, which has a permanent cable and an axial exit versus the radial exit. So again, just your choice if you want a permanent fixed cable or a removable cable.
Okay, got it. MAX48 and MAX30. That's great. And I guess the third question then is, what's the benefit to a user? Why do they care?
Well, Jeff, SICK has really packed some unique features and benefits into this product. First of all, we use a one-piece magnet, a one-piece multipole magnet. Requires no spacers. This saves on installation time, saves on parts management, and production efficiency. We've talked a little bit about the connector. In the event that the cable is damaged, it can be replaced on the MAX48N. But the best for last is that this unit has built-in diagnostics. It is continuously monitoring its own health, has historical temperature data, historical fault log data, and that can all be monitored online live through the CAN network or pulled for analytics later. Truly unique in the industry.
Okay, thanks, Jay. Hey, fourth question here. I tried to show linear movement with this little forklift back here. Maybe you can do a better job and kind of show us what the MAX48 can do.
So let's get an idea of how the sensor is actually mounted in a cylinder. I have a cutaway and clear version of a hydraulic cylinder with sensor installed. You can see at this end we have the electronics, or the sensor head, which then is wired out to an M12 connector that would be on the outside or the body of the cylinder. Inside, I'll say the fluid cavity, we can see the rod which handles the waveguide of the sensor. The magnet itself is embedded into the piston or the puck of the cylinder, and as it travels with the stroke of the cylinder, the electronics will interpret the position of the magnet and send that signal out on the M12 connector.
That was a great demonstration, Jay. Thanks. Now that kind of wraps up the fourth question, kind of doing a demonstration. And I guess this gets into the next +1 question, which is really to you out there, which is if you want to see a little more about this or learn more about the MAX48, send us an email at info@sick.com, and we look forward to hearing from you. Hey Jay, do you want to do another one of these?
Yeah, sure, Jeff.
Well, Jay, next time I'd like to talk about what's inside that blue box on the forklift, which is an inclination sensor. We look forward to seeing you next time.